Okay, students, here we go with example number 2 of taking a conjecture and proving it to be true using a concrete example and also using a formal proof. So just like last time, we're going to start over here with the concrete example. So remember, a concrete example begins with a numeric example. So I need 3 consecutive even numbers. The lowest even number I know is 2, and I don't think I want to start quite that low. I'm going to go with 6 plus 8 plus 10. So that's the sum, because I'm adding them, 3 consecutive even numbers. So if I add these things together, that's 24. And 24 is a multiple of 6. All right, but that doesn't prove anything. We've got to make it concrete. We have to make a statement that shows that it applies to all examples, not just this one. So I'm going to start the same way I did last time. Make my circle bigger next time. All right, so I've got 6 here, 8 here. I need 10. Down here, I'm going to make my circle to represent my sum. So if you remember last time on that other example, we kind of learned that if we can show things are in pairs, then we can show that it's even. If we can show that it's all in pairs except for 1, we show it's odd. So if we want to show that something is a multiple of 6, then we want to have it in groups of 6, because if it's in perfect groups of 6, then it's a multiple of 6. So I'm going to pull my x's down to my big circle in multiples of 6. Again, I can't just draw these x's down here and make them in groups of 6 without putting some thought into it, because I have to be able to explain why I knew this was going to happen, why it's going to happen every time. So to make groups of 6, I'm going to take 2 from each circle. That'll give me a perfect group of 6. I'm drawing it a little bit different this time. I want you to see that, if you express yourself well, how you draw it or explain it is not that critical. That shows me pretty clearly, what's been done here. 2 from each, comes down, makes a perfect group of 6. I do it again. These guys come down here. Another perfect group of 6. So I don't care what the quantity is. I only care that I have 2 groups of 6 down here, because that tells me it's a multiple of 6. All right, I'm going to do it one more time. So I'm going to get those 2, these 2, and these 2. Pull those down there. I've got a group of 6. So I'm building kind of one set at a time, this number that's a multiple of 6. All right, so just like last time, I've run out in the first circle. All right, so I'm out in the first circle. I go over to the second circle and I happen to have 2. And I go to the third circle and I happen to have 4, which is pretty handy dandy, since 2 and 4 together gives me that last group of 6. Now you've got to make the important statement at this point. You have to be able to convince me that you knew, or you know, that this will always happen. There'll always be 6 more once you run out in the first circle. If you think about it, you can explain that. So these are consecutive even numbers. When you run out in the first circle, This number right here is 2 more than the previous one. There's going to be 2 left here. This number is 4 more than the first circle. There's going to be 4 left here. So no matter how high these numbers are, say they're 104, 106, and 108, we would be able to make groups of 6 until we ran out in the first circle. When we run out in the first circle, we'd have 2 left in the second, 4 left in the third, and those would combine to make the last group of 6. So again, I'm going to pause the video. I'm going to write or type a statement here to help you understand why or what I need to see or hear in a proof to know that you've completed it. Okay, so you can see that I decided to type this time. And I just explained how I went about pulling, what I pulled down, why I pulled in groups of 6, how I knew that I would always have, groups of 6 to prove that it was a multiple of 6. So those are the types of things you need to add on to your drawing or your explanation when you do a concrete example. Okay, I'm going to come over to the other side here and we're going to get this formal proof done. So remember, with the formal proof, I am using variables to show that I know this is true for every number. So I am going to start the exact same way I always do. I'm going to let n be a natural number. Okay. A natural number, remember, is 1, 2, 3, 4, 5, and so on. So I have no guarantee that n is an even number. I just know it's a natural number. But I have a way to force it to be an even number. So I am going to say, hey, if n's a natural number, if I multiply it by 2, I guarantee you that 2 times n is even. That's my first even number. So let n be any natural number you want. If you multiply by 2, it's going to be even. So now I need 2 more even numbers that are consecutive to this one. The second one is 2n plus 2. And then I've got 2n plus 4. So now I find the sum of those numbers. So I add them together. Simplify this expression. So I've got 2n, 2n, 2n. That's a total of 6n. And 2 and 4 is 6. So now one more step here so that I can make my grand statement that I know this number right here is a multiple of 6. You could actually stop here as long as you give me a good explanation and say, hey, any number multiplied by 6 is a multiple of 6. And then if you add 6 more, that takes you to the next multiple of 6. I would buy that. For some reason I prefer, maybe because I'm an algebra teacher, to use factoring to rewrite this as 6 times n plus 1. So then I can say any number multiplied by 6 is a multiple of 6. So if I'm looking at this expression right here, any number, that's my n plus 1, multiplied by 6 is a multiple of 6. And that's it for the formal proof.